Okay, we are on the home stretch. Let's take a look at global requirements that are reusable. The idea here is to write requirements that you tend to want to apply to a variety of system components, not just a specific one. Typically it would be some consistency constraint, like a design constraint that you want to have enforced. Like, for example, that you are only using periodic threads or whatever are architectural constraints you want to have. Some general completeness checks, like are all the features connected, those kinds of things, or certain requirements that you can write in a relatively generic form. For example, certain security related issues or design defects that you want to check and identify so that you can start reflecting them as faults in an error model type of thing. In that case, you put those requirements in a global requirement set. You obviously don't identify a component classifier yet that they belong to. But what you can do is you can specify whether it's a requirement for a component generically, which is the default, or you can indicate that it is for a certain category of things, like a requirement on a connection. When you specify requirements, you can make that conditional. That is, if this condition comes back as true, then the requirement is inserted. If not, then it's not. And so this allows us to, based on certain conditions in the model, include a requirement or not. That is, if, for example, a component has is PALS compliant or has certain security characteristics, which is expressed by some form of a property, we can now write a condition that checks whether that property is present, and as a result of that then introduces a set of requirements and verification activities for that particular component. Given those requirements, you can make use of them in two ways. One is, as part of a requirement, system requirement set specification for a classifier, you can include a whole requirement set or an individual global requirement with an include statement. And you can indicate whether that requirement is to be used only on that component or on the component and all children. Like this was a requirement for individual connections to be verified. And here we are saying both the component that I'm attaching it to and all my subsystems I need to verify it. And up here I say only self. I can also include these things in as part of the assurance case. So you just say assure global. And so here we are now configuring this in. And ALISA automatically finds all instance model elements that are of the appropriate category, namely a component or a feature or a connection or a flow, and instantiate an instance of that requirement as a claim with the appropriate verifications in our assurance case. So that then lets you do some of these verifications instead of copy and pasting those, have them automatically inserted by ALISA itself. Back in the demo, we had a couple of examples. One example is the global requirement for connectivity, the one that we showed before. The verification plans are, again, I illustrate multiple implementations in this context. A resolute invocation and a Java-based implementation for executing it. We have it included with a import statement, down here, or on the ALISA side we can configure it in by writing assure global, like I was showing on the slide. I have another simple dummy global requirement that is a requirement that the author has to be somebody, and the verification then actually checks that there's some authorship regarding the model. So those would be an example of certain kind of consistency check type of things that you can have in there. So when you then drill down on these things here, we can now see, you know, claim R1, what is it, and find evidence. Here there was an execution problem. In this particular case, it couldn't find the Java method. So you had misconfigured something for bringing that particular library function in, or had a plugin. But again, when you define your verification plans, we can then first of all get back that certain verifications were unsuccessful, or you can offer alternatives if certain things aren't configured in. Like if you happen to not have installed a proof engine or Python, you can still verify things, and you just get back appropriate information about the ones that we are unable to run. Okay, and just for closing, some comments about stakeholder goals and requirements. As I mentioned, the primary focus of ALISA is on system requirements that are verifiable, and then automate the verification process based on these verification plans. But we obviously want to be able to connect to stakeholder requirements. And the RegSpec notation lets you specify stakeholder requirements. We call them stakeholder goals. And you can specify the whole thing in several different ways. Here's some use scenarios. The first one is you already have an external stakeholder requirement document. It's written in paper, in Word, or whatever. One way of doing that is just leave that document as is. When you now develop system requirements, you then identify stakeholder requirements that these system requirements address by a reference called C document, and then a reference into the document. So the second possibility is to actually import those requirements as a goal document. In that case, then they are structured according to the way the sections are organized in the original document, whether that is a Word document or doors or so on. We had prototypes of importers for these things, but it very much depends on the particular structure of how you organize a Word document or doors document. So we couldn't provide a high quality import tool that handles all cases. So you would have to do a tailored version of your own. The other thing that may happen in that process is as you read the original stakeholder goal document, you may want to start creating an AADL specification of the concepts that you find expressed by stakeholders. So if, for example, a stakeholder talks about a certain kind of sensor, so you introduce the concept of a sensor there, or talks about certain functions, so you can start reflecting those as ADL declarations, and possibly even point to those from the goal specification. And that becomes then the basis for developing a model. Another use scenario is where we have the system requirement already as an external document. Then we can go through a similar exercise, leave it external, just capture the concepts and the elements of what's expressed in the requirement document as an AADL model. Or you can define RegSpec proxies. That is just a RegSpec without the details of the textual description reference back into the original document, but it acts as a proxy that identifies the text in the original document. On the other hand, identifies the ADL element that the requirement applies to and gets associated a verification activity so we can automate the verification process. And we can also import the thing the same way we can import the goal document and then massage the rec spec. But the resulting rec spec specification of system requirements becomes the basis for verification and assurance plans. So on the stakeholder side, the goal specification is similar to requirement, except that it's a little less formal, more flexibility, and you identify stakeholders and reference to other documents if necessary. You can have a document-focused organization, that is, you can put the goal document with sections and subsections and then finally the goals, or you can organize it around concepts in an AADL model. One of the things that you encounter when you deal with stakeholder documents, there's lots of text, and this is actually from a real textual stakeholder document that we then imported into our structure. When you look at this, there is this concept of a simple control system, or a simple device, a simple controller, an SCS system and an SCS device, and just the word system and the word controller. The question is, are those things all the same, or are they different things? Well, this is where you then go through the exercise. What traditionally would be a data dictionary, here we can use ADL elements to represent the concepts and say, then go back to the original person and say, did you mean the same thing, or are those two different things? And we actually have then introduced a property that allows you to indicate which names are simply aliases for the same thing, so that you have some form of traceability. The other thing that we do have is a report generator that uses a mechanism called BERT within Eclipse. It's a prototype that lets you produce various traceability reports, traceability to stakeholders, traceability between requirements and goals, and so on. And